like
Yes, let me know. Do you have any idea about computer architecture?
it is like the that it's like the brain of the computer.
Okay. Anything else?
He it controls the synchronization
Synchronize operation of the computer.
of the registers and all the materials.
Okay. So what is ALU and CU and register? Any idea?
Control unit is like the one that gives signals to other registers.
Okay. Can you define what is memory? What is a register?
Registers.
Yeah.
Registers. The in they store the instructions while the computer is being run.
Okay. Now, okay, I tell you. Basically, there is a CPU. I draw here CPU, which is called processor, like this one. This is CPU. It has two parts, PU and ALU. Okay. Do you know that? CPU has two parts. The first part is called PU and second part is called ALU. This is CPU. So it coordinate the whole operation of computer. Okay, coordinate operation of computer And what does ALU? It perform actual operation. It perform actual operation. Okay, like plus, minus, divide, multiply. This kind of operation performed by ALU. And what does the register? Registers are memory units. These are memory units which store data in bits. So basically, it is connected with another memory, which I make in another slide. 1 second. 1 minute. Okay, there is a 1 minute.
Okay.
Okay, now see. Here is CPU. It is called processor, and it has two parts, CU and second is AL. This CPU is connected one kind of memory that is called cache. Do you know cache?
Cache,
Cache memory.
like we studied it.
Okay. Basically, it is the fastest memory which is connected with CPU. And there is a RAM also. Do you know RAM?
No,
Don't have idea about RAM?
no.
Okay. But this is another kind of memory. If you heard about primary memory, do you know primary memory? You will study in chapter 3. So there is
Primary.
primary memory. Which are basically two kinds. One is ROM, one is RAM. And RAM has two categories, DRAM and SRAM. Now, SRAM is basically cache, and DRAM is the actual RAM. This one. Okay. Cache basically is a faster memory which store data in megabits. So whenever CPU required instruction, it will search. Okay, it will search the memory that is called cache or SRAM. We also call it SRAM. It is faster, but low in storage. And RAM is slower than cache, but high storage. So RAM has more storage. RAM has more storage, but more storage.
Can you explain what cache is again?
Cache is a kind of memory. Cache is a kind of primary memory. Okay, it is. We also call it SRAM. The CPU search the instruction. Okay, CPU need instruction. Okay, I also connect with basically input devices. Okay, wait a second. How many topics you have done in paper chapter 3 in school? At what topic right now you are?
Uh, we are we are now studying chapter 3. We didn't study any another chapter.
Chapter 3.
Yes.
No, have you done input devices, output devices, chapter 3?
Input devices. I guess we did.
You did, no? Okay. And storage devices?
Storage devices. I guess no.
Now this is cache. This is RAM. This is hard disk. All input devices connected with RAM. Okay, now see, whenever we give data from input device, it always store in RAM. Okay. Okay. Like I'm writing on screen, it is being stored in RAM. So RAM is the primary storage. RAM is the primary storage. And from the RAM, output device shows data. Okay. Whatever you are watching on screen, it is shown on. It is given by RAM. This data is given by RAM to output device. Now CPU has internal storage. CPU has own storage that is called register. We also call it memory register. We will see different types of register. Okay. But now you should remember registers are basically internal memory of CPU. Registers are internal memory of CPU. And these registers store data in bytes. Do you know bytes?
Bytes?
Byte.
Bytes, no.
Do you have any?
Bytes?
Yeah, 1 byte. 1 byte, 2 byte, bits. Do you know
Like,
how many bits are in 1 byte?
no.
No? Okay, I tell you. Because first you need to know what is bits. So there are basically 8 bits equal to 1 byte. Okay. And 1 byte means 1 character. You got the idea? Like capital A, small a, 0, 1, any character you press from keyboard, like capital A, you press capital A or small a, it is called 1 character. And that requires space. And it will take 1 byte. 1 byte means 8 bits. 1 byte means 8 bits. Okay. And that need to be stored in RAM or hard disk. RAM and cache both are primary storage, but volatile. Do you know volatile?
No.
Volatile means they will store data until power supply. Do you have laptop?
Yes.
If you open MS Word and you type data on MS Word and you close data, suddenly your laptop restart due to any reason. What will happen? If you are writing data on MS Word, have you used MS Word or Word?
MS Word?
Yeah, for typing purpose.
I guess no.
Oh. Do you have any MS Office? Have you used PowerPoint or Excel? Any application software?
I use, yes.
Okay. When you're working on any software and you are typing something, you are writing something, suddenly your laptop will restart, what will happen? Your data will be erased. Okay. Your data, if you did not save, whenever we type data from input device, it always store in RAM. Because I always open any application software and that will I use during working, like MS Word, Excel, PowerPoint, or browser for internet. All data, all application open in RAM. And whenever we give data to a computer using any input device, it is stored in RAM. So this CPU always first it will search instruction from cache. If it does not find out any instruction in cache, then it will go to RAM. So from RAM or from cache, it will get instruction because instructions are given by user. Okay, these instructions later on stored in CPU, and CPU has its own memory that is called a register. So there are different types of register we will study. These registers store data 1 byte or 2 byte or maybe 4 byte. Okay. So if you store data 1024 byte, now remember equal 1 kilobyte. 1 kilobyte. Do you know that? 1024 byte equal to 1 kilobyte. Okay. 1024 kilobyte equal to 1 megabyte. Do you know megabyte?
I don't know.
Mega, okay, mega means 10 lakh. Mega means 10 lakh. It means 10 lakh characters stored in 1 megabyte. So you need to have 10 lakh character storage. Okay. When you basically, now what happened? Storage increasing day by day. When you have 1024 megabyte, it becomes 1 GB. 1 GB means gigabyte. Okay. Gigabyte means 100 crore instruction is stored in computer. 100 crore character are stored in computer. You have idea gigabyte?
No.
So 1024 gigabyte means 1 terabyte. Trillion means 1000 crore character can be stored in 1 terabyte. Now remember, so one of the hard disk comes in gigabyte or maybe terabyte. RAM storage normally 8 gigabyte or maybe 16 gigabyte. Cache storage is 8 MB megabyte or maybe 16 megabyte. Now here you can see. But register, now see how small is the register. It can be 32-bit, means 4 byte storage, or it can be 64-bit. So CPU has own storage that is called a register. Got the idea? So whenever you give instruction, whenever you type your data, it always store in RAM. From RAM, it can go cache. From cache, it goes to CPU. CPU access instruction from cache or RAM. Cache or RAM. When you save data, whenever you save data, like if you are working on MS Word, then it will go to hard disk. Data stored in hard disk. And it by the file name, so that you can access later on in future, next day, very next day. Okay. This thing is clear?
Mhm.
Is there
Okay.
any confusion?
So cache is a memory unit
Yeah,
like
kind of memory. Yes. But it's small. Now how you can see it is 8 megabyte or maybe 16 megabyte, but now RAM is 8 GB or 16 GB.
okay.
Okay. The difference in cache and RAM, one is storage, but cache is more faster than RAM. Cache is more faster than RAM, maybe 6 times, maybe 7 times. That is why CPU search instruction from cache first. Then if it doesn't find instruction in cache, it then go to search instruction from RAM. Because CPU need instruction to perform activity. If there is no instruction, CPU will not do anything. Got the idea? And if you save the data, it always stored in hard disk or solid state drive, SSD. Should I move to next slide?
Okay.
Okay. See, now we see further detail. Now here, basically, further detail is given. The CPU is a crucial component in computer system responsible for executing instruction and processing data. Okay. It typically includes control unit, ALU, and register. As I have shown you, CPU has 2 parts, CU and ALU, plus register, Register store data in bytes. Register store data in, I'm writing here, a register store instruction in bytes. Okay, it can be 4 byte, 8 byte, or maybe 16 byte. Got the idea?
Okay.
Okay. Now, this architecture is developed by one of the scientists who is called von Neumann. Von Neumann. This architecture is called von Neumann architecture, developed by John von Neumann in the mid 1940s. And due to his architecture, first electronic computer came in the world. This architecture introduced the concept of stored program concept. So basically, this person has given the concept of memory. Store data in memory, then reuse it. So you can access next time. Before introducing electronic computer, there was no storage facility available in computer. Computer only works on input. It takes input, process it normally, and produce output. So this was the function of old computer. But after von Neumann, it gave the idea of storage, like RAM. Okay, that person gave the idea of storage, RAM, hard disk. Okay, key feature include a CPU, direct access to memory. Okay, direct access to memory by the CPU, the ability to store program. This one is stored in RAM or later on cache, and data in computer memory, and sequential execution of stored program instruction. All instruction is stored in RAM in sequence. All instruction run after one, run after the, okay, one after the after, in a sequence. Like this is CPU. Again, I am drawing. This is CPU, CU, and ALU. This cache came later. Okay. Before cache, there was only RAM, which is connected with CPU. Okay, RAM connected with input device. We give data instruction from input device, it store always into RAM. RAM show data on screen, that is called output. Okay, so this is the initial structure of CPU. Later on, they introduce cache memory, and then they also introduce hard disk for permanent storage. Got the idea?
Mm.
Is there any confusion in this description? You can ask. Yes. Any confusion here? This is brief introduction of CPU and von Neumann architecture. Now I will show you diagram, which is given in your book.
Okay.
See this one. This is the von Neumann architecture. It says there is a CPU. This is the whole part of CPU. This is connected with different register. One register is called MAR. One register is called program counter. One register is accumulator. One register is called CIR, and one register is called MDR. All register have their own role, okay, or activity. Now remember again, I told you earlier, these registered instruction in bytes. Okay, these bytes can be 4 or 8 or 16. Here you can see how low storage it has. So according to storage, its capabilities to store, the speed of computer determined. Now CU and ALU. CU operates the whole operation. The purpose of CU means control the activity of the operation or computer. ALU perform actual operation, plus, minus, divide, multiply. We will discuss in detail later on. Now here it says, whenever computer picks the instruction from the memory, the first operation start by this one, program counter. Program counter program counter point to the next instruction to be fetched by the CPU. The current instruction always hold by CIR on which CPU is working. Instruction will have its address. Address is stored by MAR. MAR is the memory address register, which hold address of instruction. Okay.
Teacher?
Yeah. MAR hold address of instruction on which processor has to work. The actual data hold by memory data register. Okay. Actual
Teacher?
data. Yeah. What did you say? What did you
Can
say?
you can you explain the program counter again?
I explain. Just okay. Just later. 1 minute. The basically program counter is store data. Okay, I write it on screen. It point to address of next instruction. To be processed. Basically, see, program counter hold instruction of next instruction to be processed, address of next instruction to be processed, because current instruction already being processed, and that is held by CIR, current instruction register, on which processor is working. That is held by CIR. And after this instruction, which has to process, which is held by PC. It point to address of next instruction to process. Okay, when CPU is finished this instruction, then it will check program counter. Second instruction, third instruction, maybe fourth instruction. Okay, and from program counter passes on its data to MAR. MAR passes the data on MDR. Okay, remember the sequence. And MDR passes the instruction to accumulator. Okay, plus CIR. Result always stored in accumulator. Result always stored in accumulator. I just show you its content, table content. Here, see. What does the CIR? This register store the current instruction being decoded and executed on the processor working on current instruction that is held by CIR. Any confusion here?
Yeah, what does decode and executed means?
This is the operation. I will discuss basically next few slides. Decoded means actually the first stage of computer to get the instruction is called fetch. The first stage to get instruction from memory. Wait a second, I show you here in blank slide. Now see here, this is CPU. This is CU, and this is ALU. This is connected with memory. Like 4 plus 5, I have to get 9. But this addition will be performed by CPU. Okay. This instruction get by CPU, by CU. The CU get the instruction from memory. This process is called, or this stage is called fetch. What do we call it? Fetch. Fetch means to get instruction. Okay. To get instruction from memory. Then it performs decoded by CU. Decoded means decoded. To interpret the instruction, to translate the instruction. We can say to interpret the instruction.
What does interpret mean?
Interpret means to perform addition. CU tell ALU what it has to do. CU will tell ALU has to add the two numbers. This is the interpretation. Decoded means translate the instruction, what has to be done by the ALU. Because ALU does not know. ALU only know because ALU has different arithmetic function like addition. ALU can do addition, subtraction, multiply, divide. Any mathematical function can be done by ALU. this addition will be done by ALU. Okay. CU will not do. CU tell ALU that ALU has to perform addition. This is the decoded part. This is the decoded part. So this, but who will do addition? ALU will do. Okay. So this process is called, third stage is called execute. Execute means to perform operation. To perform operation. Okay. And this operation is basically addition. This will be done by ALU, not CU. CU get the instruction and decode the instruction. These two, it is always done by CU. Got the idea? Now,
Okay.
fourth function is to store. Where to store? In accumulator. Accumulator is one of the register which I have shown you. Accumulator is a kind of register which always result of the ALU. Output or result always stored by ALU. Okay, this is third. Fourth function is store, and this result transfer to RAM 9. So this is called fetch execute cycle. We call it fetch execute cycle. So this cycle perform every time.
Teacher.
Can you say
They call
fetch, decode, execute cycle? Fetch, decode, execute cycle.
fetch, decode, execute cycle.
Yeah, fetch, we call it fetch, decode, execute cycle. It will come in your chapter 3 later on. Okay. This is the next
Teacher,
topic. Okay.
decode means like to transfer the instruction to the operation, right? To tell it what to do.
Yeah. Fetch mean what? Your fetch mean getting instruction from RAM, instruction given by user, and it is stored always in the RAM. Okay. And CPU, the CU part of the CPU will get instruction from RAM. Then it will interpret or translate the instruction. Okay. After translation, it will tell ALU. ALU has to perform which kind of operation. So this is done. This is told by CU. CU will tell ALU that it has to do addition, it has to do subtraction, it has to do multiply, it has to do division or remainder. Any operation which can be done by ALU will be told by CU. Okay.
Okay.
This is called fetch, decode, execute cycle. It is always done in CPU and app. Okay. It gets instruction from memory, processed by CPU, and then stored again memory. Now remember one thing. Result always is stored in accumulator. Result always stored in accumulator.
Okay.
1 second. Okay, you got the idea?
Yes.
Now we again go to the table so that you can understand the rest of the register. Here see. So accumulator, as I told you, this register used when carrying out ALU calculation. It stores data temporarily during the calculation. As I told you, accumulator store the result of ALU. Okay, ALU store always its result into accumulator, and from accumulator it transfer to RAM. Now MAR, this register store the address of the memory location currently being read from or written to. So basically in RAM there is a location or address which is generated in RAM for any instruction, for any data. This register hold that address of data which has to be processed. Okay. And data itself stored in MDR. this register store the data which just had been read from memory or data which is about to be written into memory. Actual data held by MDR.
Mm.
Okay, you got the idea? And program counter, as I told you, this register store address where the next instruction to be read can be found. It holds the instruction of address of next instruction to be processed. Okay, these 5 registers you have to study in your chapter 3. Okay, for every instruction to be processed, these register must be active. So again, go back. Here you can see component of CPU. The first one is ALU, perform arithmetic and logic operation during program execution. Just as I told you, plus, minus, multiply, or divide. These kind of operation done by ALU. Control unit read instruction from memory. Now this is fetch. This is fetch. Reading or getting instruction from memory is called fetch. Interpret them. Okay. Decoding. Using the fetch, decode, execute cycle. Okay. And execute performed in ALU and generate signal for other component. So CU basically synchronize other component of computer to be ready for operation. Register are basically special purpose storage location within the CPU used for temporary data storage. Got the idea? As I told you earlier, register in the von Neumann system can be general or special purpose, and they play a crucial role in the fetch, decode, execute cycle.
Mm.
Okay, you got it?
Mm-hmm.
Any confusion?
Yes.
Any confusion here?
Like, I'm confused about memory that address register and memory data register.
Okay. MAR?
And like,
This topic have you done in school?
yes, I did, but they always confuse me.
It confused me. Okay. So now, right now it is clear.
Now, like,
Okay. Where you have confusion?
I'm confused about the roles of the memory address MAR, MDR, and PC.
Okay. These are description given for each register. Okay. Wait, I show you something else. Now see the sequence. First, see this one. PC basically hold address of next instruction. Content of PC copied into MAR. Okay, the first step. Content of PC means PC hold the address of next instruction to be processed. So obviously, when processor finish the first instruction, it will search for second instruction. The second instruction address hold by PC. So when CPU come to the PC, it transfer its data to MAR. PC is incremented by 1. Now PC will increment. Now PC will point to third instruction. Got the idea? Now PC will point the third instruction. Mean after finishing second instruction, CPU will come and search the third instruction, and it is already pointed by PC. What will happen? Data stored at address shown in MAR is copied into MDR. It copied into MDR. So MDR, okay, from MDR, it goes into CIR. And from CIR, CPU works on. Now CPU. Whatever data held by CPU or CIR, now CPU work on maybe 2 plus 3 equal to 5. This operation has to be done. This is the operation. So from here, fetch, the first step, fetch. Okay. Second step is decode. It has always happened whenever it perform any operation. The third is execute. These three operations always done by CPU whenever it gets instruction from the memory.
Mm.
Okay, got the idea. I show you this one also. Here you can see flowchart. Start. Like any instruction, yes. If no, again come to start. It check any instruction, yes. The program counter contains the address of memory location of the next instruction which has to be fetched. Okay, this one is clear. This line is clear. This address, okay, this address is then copied from PC to the MAR. Okay, this is done using the address bus. Okay, there are three buses: data bus, address bus, and control bus. Data always move through data bus. Its address moved by address bus, and instruction regarding this operation hold by or moved by control bus. The content instruction at the MAR contained in MAR are then copied temporarily into the memory data register. So whatever content is stored in MAR are transferred to MDR. The content data itself of the MDR are then copied and placed into the current instruction register. As I show you in the previous diagram, the value in the PC is then incremented by 1 so that it now point to the next instruction. In this case, third instruction, which has to be fetched. Obviously, if processor has finished first instruction, now it is working on second instruction. After second, it will process on third instruction. The instruction is finally decoded and then executed by sending out signal via the control bus to the various component of the computer system. Now it has been finished. Any more instruction to service? Yes. Continue process. Again, this process will continue. If no, it will end. So you need to remember, I show you again. Here, this is a summary of fetch, decode, execute cycle. Okay, MAR. Content of PC transferred into MAR. Content of PC is basically incremented by 1. You can say updated. PC is updated. So it will point to the next instruction. After finishing the current instruction, data stored at address shown in MAR is copied into MDR. And content of MDR copied into CR. So you can say that PC data stored in MAR data stored in MDR, this MDR stored data in CIR. And from CIR, okay, CPU works on that instruction. Got the idea?
Okay.
Any confusion till now?
Teachers,
Yeah, I'm here. What do you want to ask?
okay.
Okay. Now see here. Basically, these are buses. Buses are electrical path, okay, which transfer data, address, and instruction. These three things are data. Remember, buses are electrical path. Buses basically electrical path. Have you heard about buses? Move data,
Yes.
instruction, and address. These three all data by data bus, okay, address by address bus, and instruction by control bus. So this thing, whatever we have to move, we have to use buses. Address bus basically unidirectional bus carrying address throughout the computer system. And data bus, bidirectional bus means you can write and you can read, allowing the data transfer data between CPU, memory, and input-output device. Control bus also bidirectional bus carrying the signal from the control unit to other component in the system. Basically, when operation need to be performed, CPU alert other component of computer so that other component must be ready during operation. Must be ready during operation so that they can play their role. Got the idea?
Okay.
So this is the way how computer perform working on instruction. Again, fetch, decode, execute cycle. A fundamental cycle in CPU operation where instructions are fetched from memory, decoded, and then executed. So remember these three steps. Involve the use of address bus, data bus, and various registers.
Okay.
So whenever operation performed by CPU, so it is basically the fetch decode operation always happens. So one thing more, role of system clock. So timings are given to all component of computer so that every component must be ready at the time when operation need to be performed. The system clock produces timing signal on the control bus, ensuring synchronization means same of data flow and program instruction. So CU generate timings through system clock, tell other component at what time they will perform an instruction or operation. Got the idea?
Okay.
Here you can see fetch again. Data and instruction are fetched from memory into suitable register. The fetch instruction is decoded for interpretation. Okay. Control signal are sent to appropriate component, allowing the execution of the decode instruction. These three steps you must remember. Okay. So basically, how I prepare, I will discuss paper-based question regarding topic. Okay. So I will when our topic is finished, I will discuss. Here you can see some question. When this topic is finished, so basically this is the same like this one. Here you can see different question, different answer. I will also discuss paper-based question. Now this is the paper-based question. Okay, kind of that. So here I show you further question. Like these are now here you can see how many questions you can do with the related topic. Now this is the paper-based question. This question has come recently, November 23, kind of, maybe June 23. These are all latest questions on regarding this chapter, this topic. First, I will finish topic, then I will discuss with you CIE question related to that topic.
Okay.
Got the idea? So
Yes.
but from day one, you will be attached with the CIE papers, not the end, for every topic. Okay.
Okay.
Any confusion till now?
No.
Okay, so enough for today.
Okay. Thank you.
Okay, Allah Hafiz.
Allah Hafiz.